This video answers some frequently asked questions about tests of significance. Some of these come up on the AP exam from time to time, so it's good to know the answers to these. First off, what is a p-value anyway? A p-value is the probability of getting a test statistic that it is far or farther from zero, or a sample statistic is far or farther from the h-naught value than the statistic we actually got if the null hypothesis is true. Another way to say it is if we were to take many random samples of the size we used and the null hypothesis is true, then the p-value would be the proportion of all samples that would give us a test statistic that is as far or farther from zero than the statistic we actually got. Here's a picture that illustrates a p-value. We have the sampling distribution of our statistic. This is our sample statistic. The null hypothesis says a parameter takes a certain value. We calculate a value for our statistic from our sample data. The probability of getting a statistic that is farther away from the h-naught value is the p-value. So this area here under the curve, that's what the p-value is. Now the sampling distribution comes from repeated random sampling. You take samples of a given size many times. The sample statistics that we generate will follow a distribution like this. So this p-value can be looked at as the proportion of all of those sample statistics that would have a value that is greater than or equal to this one, that is farther away from h-naught than the one we actually got. Some people ask, isn't the p-value just the probability that the null hypothesis is true? The answer is definitely not. The null hypothesis is either true or not true. It contains a parameter and a value. Nothing about either of those things is random. Since the null hypothesis is not random, you can't attach probability to it. What is random in a test of significance is the sample. That's the important thing to keep in mind. The sample is what is random. Your data come from a random process, random sampling, or random assignment to treatment groups in an experiment. That's what's random when you're conducting the test. The null hypothesis is not random at all. The p-value is going to tell you how likely you are to get a random sample that is as or more extreme than the one you actually got if h-naught is true. It's not going to tell you the probability that h-naught is true or not. Here's the third one. Isn't the p-value just the probability that the null hypothesis is false? Well, read the answer to that question right there again. Read it as many times as you need to it sets in. You have to remember that the null hypothesis is not random. It has no probability attached to it. Can you ever accept the null hypothesis? Well, no. Your options are two. You can reject the null hypothesis and find evidence in favor of the alternative, or you can fail to reject the null hypothesis and fail to find evidence in favor of the alternative. You can never prove the null hypothesis is true. If you say, I accept the null hypothesis, then it sounds as if you're claiming to have proved it. You have not. You cannot prove the null hypothesis. No matter how hard you try, you can generate samples and do tests of significance until the sun burns out. You will never be able to prove it. Okay, so say, I reject if your p-value is small enough, or I fail to reject if your p-value is not small enough, and that's it. Do not say I accept the null hypothesis if you fail to reject. It's not the same thing. Next, what level of significance should you use? Well, you have a choice. You can choose any alpha level you want. The most common values are 0.05 and 0.01, but you can use some other value. I wouldn't generally use a value that's bigger than 0.05. Some people use 0.1. That means they would reject the null hypothesis if they get results that would happen by chance as often as 10% of the time. And that is a fairly weak standard for most people. Most people want 5% or 1%, or perhaps even less often than either of those. But you can choose. Now, when you choose your alpha level, either one of these or some other value, think about these things before you conduct your test. In fact, even before you gather your data, choose your alpha level. What are you going to base that choice on? Well, it's going to be based on this. the possibility that your decision about the null hypothesis might be wrong, and whatever consequences of an incorrect decision might be. And we'll talk about different ways that you can be wrong in the next video, but think about those things when you choose the alpha level, and then choose it before you get started. Okay, before you conduct the test, in fact, even before you gather your data, you want to think about that. And a lot of what you're going to do in the test is going to depend on that particular choice that you make. So be careful about that choice.